My name is Danny Nowlan and I'm the Director of Chassis Sim Technologies. Today, in this video tutorial, I'm actually going to be giving you all a little bit of a treat. In November 15, 2014, I gave a presentation at the Professional Motorsport World Expo in Germany entitled Why You Are Mad Not to Use Simulation. And due to popular request, I'm going to be re-presenting this tutorial today in this joint Chassis Sim tutorial presentation of Dan's Vehicle Dynamics Corner. This presentation had its origins over, quite frankly, quite a few years. And really, there's a couple of recurring themes that I have seen right throughout the last couple of years, and if anything, for as long as I've been in business with Chassis Sim. And here's the thing. Simulation is thought of as this nice optional extra for well-funded teams. However, if you're serious, simulation needs to be an essential cog of what you do. And here's the thing. A race car simulation will force you to understand your car. And once you can understand your car, you can play the what ifs you've got a really good basis for playing the what ifs. And I'm going to show you some key examples that really illustrate this. And the other thing too that I also want to add before we get into this, yes, why you are mad not to use simulation? Yes, I do have a vested financial interest in making sure that you guys use simulation, but I just don't say it. But this presentation I'm giving you today isn't just because I've got a vested financial interest in this. Being the principal of Chassis Sim Technologies and having used this in anger now for almost 20 years, I have seen firsthand how Chassis Sim has transformed the way that people engineer a race car. And I guarantee you, once you get your head around what Chassis Sim can do, you'll never go backwards. And really, this is really what I want. This is really the key reason why you are mad not to use simulation. Indeed, I would say bark raving mad not to use simulation, and Chassis Sim in particular. So let's get started. The thing that simulation tells you about your car is even before you've done any setup sensitivity analysis, you can glean so much from the correlation. Let's have a look at this plot of simulated versus actual data. Actual data is colored, simulated data is black. Let me walk you through the traces. We've got speed, steered angle, front pitch, which is the average of the front dampers, rear pitch, which is the average of the rear dampers, and we've got lateral G and longitudinal G. Now, looking at the two plots, the front pitch isn't too bad. The rear dampers, there's a really big discrepancy there. Now, most people at this point would take one look at that, throw their hands in the air and just figured, we've just shoved 15 grand down the toilet. Well, I can tell you right now, you haven't shoved 15 grand down the toilet. Your simulator has just told you there's a very, very big hole in the Aero map and that you need to do something about it. And here's the thing. I have now lost count of the number of spec formula cars I've seen with really glaring inaccuracies in the information that's been provided. And the great thing that simulation brings to the party is it gives you an instant light into that behavior. The other thing that it gives you is sanity checking. If something is wrong, it's going to show up really, really quickly. Let's take a look at this particular plot where the motion ratios have gone wrong. And so what we've got here is that we've got just a smooth circuit approximation. Again, actual data is colored, simulated data is black. So what we've got speed, front dampers, and rear dampers. Have a look at what's going on with the rear dampers here. The rear dampers are significantly lower than the front dampers, and really this was the motivation for this, and this was actually from one of my sports car clients who gave me a call and said, Danny, the Aero modeling isn't working, what are we going to do? And I instantly just started to do the numbers, and when they were going at CLA numbers like 25, I figured, okay, something is seriously wrong here. And when I ran through that, I just figured, hang on, something just isn't making sense. And they were running a very, very aggressive rear third spring. So when I inverted the motion ratio, all of a sudden, that correlation there tidied itself up for. And here's the thing that simulation brings to the party. You can look at that straight away. So consequently, don't leave home without it. Aero modeling. This is something that I have spoken and I've written about on many occasions, and quite frankly, I don't care that I'm mentioning it again, because quite frankly, as far as I'm concerned, I am going to continue to mention it until I can see the race engineering community starts to get this right, and for that, I bear zero apologies. So, one of the powerful things that Chassis Sim brings to the party is the fact that it can take race data and back out the error. Yet the mathematical basis for it is so easy because it just comes from a simple hand calc. And this is an example that I've presented many times before. So what we've got here is that we've got some basic F3 numbers. We've got our motion ratios, dampers, spring rates, torque at the RPM, rolling tire radius, lateral G, speed, gear ratio values, masses, heights, wheelbase. And to work this out, all it is a simple all it is just a bunch of simple hand calcs. I present it at every boot camp that I do. I have presented it on a number of different race car engineering articles, and I will continue to present it until until guys in the race engineering communities across all the various platforms, until I start to see a market improvement of this. I am still shell shocked at the number of so-called race and data engineers who can't do this. And a little hint for those people who are finishing up their engineering degrees who have just gone into the race engineering workshop. If you guys cannot do this and you work for me, I will fire your ass. It's as simple as that. So don't leave home without it. The other great thing that you get from simulation is that we can tie all this together in an Aero map test procedure. Now, this is something I've spoken about on a number of earlier tutorials, but what you're seeing there is the blueprint about how you generate an Aero map from race data. So as far as I'm concerned, you got rocks in your head if you're not looking at this. It's as simple as that. So you do a right height sweep, and then you do a wing wing sweep. And I presented a very detailed tutorial on this before, so that is definitely worth your while looking up. And again, it illustrates the resonant power that's within simulation. Now, in terms of what this has done as a result, what we've got here is the Aero map for the first generation A1 GP car, which was a really critical element in unlocking what that car could do. Again, when I started to do this, everyone thought that I was this magician. All I did was use the tools in front of me and worked through the process. And this, ladies and gentlemen, is why simulation needs to be such an essential element of what you're going to do. Because how are you going to set up the car? Basically, stick your finger in the air and see which way the wind is blowing. This is the real key of how to be an engineer and doing your work properly. Tyre Force Modelling, as far as I am concerned, it is one of the jewels of the chassis. It is one of the jewels of of what Chassis Sim brings to the party. Indeed, I regard it as almost the Chassis Sim's crown jewels, because it was created to take race data and to back out what the tyre model was doing. Because the way that it works is it works off a bunch of track replays. Ladies and gentlemen, I have lost count of the number of times this particular toolbox has saved my neck, so don't leave home without it. Now, and here's your process to go through and do it. You create the 2D model, you optimize your camber and your slip settings, you tune in your temperature tire model with the tire properties, and then you go on to create the 3D tire model. This, ladies, now I've given a number of detailed tutorials on this, but that is your game plan. That has produced tire models without tire test rig data for formulas as diverse as GP2, GP3, V8 supercars, sports cars, and a multitude of other different formulas. As far as I'm concerned, if you never ever do any setup sensitivity analysis, the worth in Chassis Sim is worth just doing this, so don't leave home without it. Now, what do you expect from tire modeling? Here's the result of tire modeling using the track replay simulation. And as you can see, obviously the speed, throttle, and steer inputs are all the same because it's a track replay. Take a look at the correlation of the lateral G. This, ladies, and particularly the longitudinal G, this is the thing, ladies and gentlemen, that when you do your tire modeling right, it brings to the party. This is the payoff. And you ignore this at your peril because you can divine so much from this data. But the great thing is, everything I've just talked about can be combined all into a process. If there's one thing that I've learnt the hard way, it doesn't matter how clever you are and it doesn't matter how utterly brilliant you are. If you cannot break down what you do into a process, you, you're a shot duck. You're dead in the water. So here's the Chassis Sim process. Step 1, you choose a template that closely resembles your car. Step 2, you put in the correct setup. If needed, you validate the Aero from a hand calc. If you need to, you do the Aero modeling. But if your template's actually pretty good, steps 3 and 4 can almost be approximated by just tuning in the CLA and CDAs and aero balance offset of the rear wing. You construct your curvature and bump profile. You refine the results using road camber, bump scale factor, and grip factors, and your tire modeling. Bottom line, folks, this is not secret squirrel stuff. This isn't black magic. It is a process. And once you get used to this process, it will transform the way you engineer a race car. And here's the payoff of when you get it right. What you are seeing there, ladies and gentlemen, is actual data compared to simulated data. Actual is colored, simulated is black. We've got speed, throttle, front dampers, rear dampers, steered angle, lateral G, longitudinal G, front and rear roll. This is off a street circuit of a touring car. This is, as far as I'm concerned, if you're at this point, you can now start doing your setup sensitivity analysis. And once you've done your job right, that is Chassis Sim business as usual. And now it's time to give you a little bit of a preview of what's coming down the road, which I gave at both PMW 2014 and PRI 2014. We are about to combine the lap time simulation with driver in the loop simulation. So what we've got there is that's going to allow you to do your lap time simulation and then turn around to your race car driver and go, right, give this a go. Because part of the challenge that we face as race and data engineers is that we'll look at data. If we've got a tool like Chassis Sim, we'll then try our changes, but then there's a whole big uncertainty of are these changes going to work or not? As engineers, we're about 90-95% certain, but just remember, a lot of this is too a mental game in terms of getting the driver's confidence up. If you've got a tool that they can drive your model with that sort of correlation, ladies and gentlemen, then you are going to be in a much, much better place. And the payoff part too is here's a comparison between the lap time simulation, which is colored, and the driver in the loop simulation, which is black. Now, it's not exactly spot on because this is me driving and I don't claim to be the best race car driver in the world, but here you can see the resonant power of the lap time simulation and the fact that it is, of the driver in the loop simulation, and the fact that it is very, very close to what our lap time simulation is. Because I mean, they're using exactly the same vehicle model. I mean, the only differences between the two vehicle models is that we threw in the effects of self-aligning torque. That's it. So this, ladies and gentlemen, is really the resonant power that you get with using simulation, because it just brings so much to the party. Some parting thoughts. As far as I'm concerned, simulation needs to be a critical part of what you do. What I'm about to say is going to really annoy some people, but as far as I'm concerned, if you're not doing this, I hate to say it, other professions beckon. And this is why other professions beckon. If you don't do this, it can pinpoint things things that are wrong with the car, and it will do it very, very quickly. Also too, you can use your data to create aero and tire models, and this can be used for your lap type and driver in the simulation work. And really, to sort of sum up this presentation, I'll never forget when I was in London on business and I was trying to keep myself awake, and just walking around, which is something you have to do when you got jet lag. I was thinking about it, that I was just rephrasing this another day, and it really hit me in the nose. If someone could offer me a tool as a race and a data engineer that could take my existing data, reverse engineer my aero and tire models, and allow me to run virtual laps on the race car, it just hit me in the nose. You'd be absolutely nuts. Not to consider it, And B, you'd be even further nuts if you actually didn't spend a lot of time actually getting up to speed for it. And that, ladies and gentlemen, is the reason that you are absolutely mad not to use simulation. So to conclude this presentation, don't take my word for it. Go to our online simulation website, get started with our online sim. Work through the Chassis Sim tutorial, and you're going to see for yourself just what a valuable tool simulation can be. And I look forward to catching you up in either the next Chassis Sim tutorial or the next episode of Dan's Vehicle Dynamics Corner.